Well, hey there, kiddos. Today we're going to talk about more factoring, except today we're going to talk about how to factor using something called the box method or the AC method. They're both the same. They both will get you to the same place, but it's just like when we multiplied polynomials, we either did double distributive or box. This is the same kind of thing. It's two methods to get to the same place, and I will show you both, and then you can pick the one you like. But first, we have to deal with algebra tiles. These pictures and these images will show up, and if you are not familiar with them, you're going to run across a test question that is going to be difficult to answer when it shouldn't be. So this is why I keep harping on this and keep showing them to you, because I would like you to be able to see them. So the first question asks you to use the algebra tiles to factor the polynomial. When we're factoring, all we're doing is coming up with the two things that multiplied to give you this. This is the answer. I need to know what went here and what went here to make this. And so that all we're going to do is we're just going to work backwards, okay? So in order for me to get this first row right here, I have to think about what went right here in order and right here in order to make that happen. And so all I have here is an x squared and then a whole bunch of x's. And so when you are factoring using algebra tiles, what I'm wanting to do is I need what goes right here to be the same length as the length of what is right here. Well, if I were to put this up next to that, I see that the length of an x squared is an x. So what goes right here is an x. And in order for me to take this x times whatever was up here and make that x squared, I also had to have an x here. And so there's the first part of my factor. I know I have an x and I have an x. Now for the next row. Somehow I had to take this negative x and all of these negatives that were right here. Okay, and I had to take something that was right here and be able to multiply it times whatever was up here to make this. Well, in order for me to end up with a negative answer, it means I had to have a negative number somewhere. And again, I need the length of whatever goes here to match the length of this right here. So I know I can't draw an x because an x is too long. So what I have to draw is a little 1. It's one of the little ones because it's the same length. And I'm going to do a shaded one because I know I have to have a negative. Same thing for this row. I've got a negative x and then all these lovely little negatives right here. Well, my length also needs to match, and so again, I have another 1 right here so that my lengths match. And it's a negative 1 again, so I can take care of my negatives. So now I go up here to the top and we'll talk about what we need in order to make this, okay? So I have a positive x and then two negatives. I need to be able to multiply this negative times whatever is here and it make a positive. I also need to be able, so like over here, the length of whatever goes up here has to match the length of this. So again, I can't draw a long rectangle x because it's longer than this side. So I'm going to have little ones. The only thing I have to determine is whether these ones are positive or negative. And so here's how I test it. This x times this x made x squared. And then this x times this 1 has to give me a positive x, which means this has to be a positive 1. And we'll double check and make sure it works out in a minute, but you'll see that when I do this negative 1 times this positive x, it makes a negative x. And so it takes care of that. And I need one of these little ones for each one of these x's. So I have 1, 2, 3, 4, 5, 6. So I need 6 ones right here. And so they line up. And if I go double check, okay, so x times x is x squared, x times 1 is x times 1 is x, and I do that 6 times, and then negative 1 times x is negative x, negative 1 times x is negative x, and then the negative 1 times the 1s makes negative 1s, and so it does work out. And so now I got to write down what my factors are. Well, I'm just going to turn this into algebra. This becomes an x, and that's a negative 2, and this is an x and a positive 6, so my two factors are x minus 2 and x plus 6. So the next question asks us to fill in the tiles to make a rectangle, and then I have to find the two factors of each trinomial. That's what they're asking us to do. So I have to use algebra tiles to create a rectangle like we had up here in number 1. So I'm going to create something that looks like this, but it has to match this polynomial, x squared plus 5x plus 6. So I know I need an x squared. So the first thing I'm going to do is I'm going to draw my big x squared. So there's my x squared. Then I need 5x. So I need 5x's total, and I'm not just going to write them all out in a line here. I need to be able to make a rectangle, so I'm going to split it. 5x will break up into 2x and 3x, because 2 plus 3 makes 5. So I'm going to split it up. I'm going to put 2x's this way, and then I'm going to put 3x's this way so that I can get all 5x's in here, and that way I can make a rectangle. Otherwise it doesn't make a rectangle. It's just a jumble of stuff. And then I got to have plus 6, so I need 6 little ones. Well, there is just enough space here for me to put 6 little ones and fill in this remaining spot, and now I have a rectangle. And so now I'm going to factor, just like I did a minute ago with the one up above. We're going to go ahead and do the factoring like we did. And so, just like I did up here, x squared, I need the length of whatever I have out here to match the length of this. So that's going to be an x. And I'm in luck here because everything is positive this time. This is also an x, because that's the only way I get an x squared is to do an x times an x. Now, x times something right here had to give me an x. Well, in order for the lengths to match and for that to happen, I had a 1 here, I had a 1 right here. And then down the side here, something times x had to make an x. And so in order for my lengths to match and for that multiplication to work, I have 1's right here. So what I ended up with was x plus 3 and x plus 2. So those are my two factors. And so now let's talk about how to do this without having to draw the algebra tiles, because we don't always want to do that, and sometimes it's not much fun. So we're going to factor these trinomials doing something called either the AC method or the box. And I will show you both methods, and then you can pick the one you like the best, and I'll just alternate. So AC method is called the AC method because when you have a trinomial, it has 3 parts, A, B, and C. And the first thing you do in the AC method is you take the A and multiply it times the C. And I'm going to draw this x here, and it's going to serve a purpose. So when I do 3 times 4, it makes 12. And it actually makes 12x squared when I multiply 3x squared times 4. So up here is going to be my 12x squared. That's what I multiplied to equal. Down here in the bottom part of my x is going to be this middle term, 8x. What goes here and here are the numbers that I am looking for in order for me to be able to split this up and turn it into something I can factor. I've got to split this 8x up like I did up here when I was making my rectangle. I split this 5x up into the 2x and the 3x. I'm going to do the same thing with this 8x because I need to be able to split it up so I can do the grouping method or the box method in order to factor. So we're going to have to do this. What I need to figure out what two numbers are going to split up to make this 8x is I've got to come up with two numbers that multiply to make 12 that also add up to equal 8. So they multiply to make 12, add to equal 8. So I'm going to start listing factors of 12. Okay, so here's how I do it. I'd make myself this T-chart, and I know that I need it to equal 12. Well, factors of 12, 1 and 12. Well, if I do 1 plus 12, that equals 13, not 8. So those aren't them. So then I have 2 times 6. Well, 2 plus 6 makes 8. So there are my two factors. So I'm going to have a 2x here and a 6x here. And order does not matter here, as long as I get those two numbers in there. So these are my two numbers. I'm going to split this 8x up into equals. So I'm going to rewrite this trinomial as 3x squared. And instead of 8x, I'm going to put 2x plus 6x. So I'm going to put 2x plus 6x, because if I put those together, they make that 8x, and then plus 4. Now I can do what we did today in class, and I can do the grouping method. So I can group these together, and I can do the GCF and factor. So the greatest common factor for 3x squared and 2x is just going to be a 1x, because that's the only thing they have in common. And once I factor out that x, I have a 3x left and a 2. Then my greatest common factor for 6x and 4 is going to be a 2. And if I factor out a 2 from the 6x, I have a 3x left plus 2. And you'll notice my parentheses matchy-matchy. So my two factors are 3x plus 2 and then x plus 2. And that's your solution. Here is your answer. You have factored that trinomial. And if you want to be for sure, do the double distributive property. See if you get 3x squared plus 8x plus 4 is your answer. If you do, you're correct. If you don't, you made a mistake. So now let's talk about the box method, because it's very similar. It's going to work the same as what we just did, except we're going to use a box instead of the grouping method. But we're still going to be doing the same kind of thing. So again, you start the same way. We have our little x here, okay, and we're going to multiply a times c. Well, 4m squared times 5 becomes 20m squared. And then I need this middle term, this 9m, goes down here. So I need two numbers that will multiply to make 20m squared and add to make 9m. So again, I make my t-chart, and I know that I need to list the factors of 20, and they need to add up to 9. So we're going to start listing our factors of 20. Well, 1 times 20. If I do 1 plus 20, that's 21. It doesn't work. 2 times 10. Well, 2 plus 10 is 12. That still doesn't work. 4 times 5. Well, 4 plus 5 is 9. There are my two numbers. So I have 4m and 5m. Now to do box method, it's very similar to the grouping method. It just takes up a little bit less space. So we draw a box, just like before. We're going to split it into 4 pieces. The first term of your trinomial, 4m squared, goes here. The last term, 5, goes here. And then the two numbers you just came up with go in these other two boxes. It doesn't matter which one goes where, as long as one is in one box and one is in the other. So now what we're doing, what we did before is you would line out what goes outside the box and we would multiply to get the inside. Now we're starting with the inside of the box, and we're going to work backwards to get what goes outside, because what you're looking for is what goes outside that box so that you could have the two factors. So we're going to go row by row and column by column and pull out the GCF. Just like we did, I think I showed you this yesterday. So I have 4m squared and 4m. Well, the greatest common factor between those two things is going to be a 4 and an m. For 5m and 5, the greatest common factor there is a 5. Then for this box, 4m squared and 5m, the only thing they have in common is an m. And then for 4m and 5, the only two things those two numbers have in common is a 1. So here are my two factors. One of them is 4m plus 5. The other one is m plus 1. And so that is your solution. That's how I got it, and I used the box. So we started inside and worked out. So now let's do another one. So we'll do number 5. We'll do it here with the box method like we did this other one. So I have x squared plus 11x plus 28. So we're going to do the same thing. We're going to multiply a times c. And when I do x squared times 28, I get 28x squared. And this 11x goes here. And so then I'm going to make my t-chart. And I need factors of 28. Well, 1 times 28 makes 29, so those are not them. Okay. 2 times 14 makes 16, that's not it. 4 times 7 is the next one I can think of, and 4 plus 7 makes 11. There they are. These are your two numbers. So you have 4x and 7x. So let's do the box method. So we're going to draw our box. We're going to fill it in. So the first term was x squared, the last term was 28, and then these two numbers fill in the rest. So 4x and 7x. And then we're just going to pull out the GCFs. So for x squared and 4x, the only thing they have in common is an x. For 7x and 28, their GCF is a 7. X squared and 7x, the only thing they have in common is an x. And for 4x and 28, it's a 4. And so my two factors are x plus 7 and x plus 4. And you have to write it this way because factors are the two things that multiply to equal this. So you got to write them as a multiplication problem, but that's it. Now number 6 is a little bit different because if you will notice, number 6 only has two terms. Number 6 is really a special product called a difference of two squares, but we don't know how to do that yet. So we're going to factor this using the method that we just learned, but we have to do something to this first. It needs to have three terms. So this is the same thing as 4x squared plus 0x, because there is nothing in the middle, minus 9. And we're going to factor just like we did before. Okay, this time I'm going to use the AC method so you can see this grouping happen again. So we multiply a times c together. And when I do 4x squared times negative 9, I get negative 36x squared. And when I add them together, I need it to equal 0. My pen's wigging out on me, 0x. So we're going to make our t-chart. And I'm glad that we finally have this one because you need to see how it works with negatives. So I'm going to make my t-chart and I'm going to do it over right here because I need space. So I need them to equal negative 36. So when I list factors, I've got to think about the fact that it's negative. So my first ones are negative 1 and 36. Well, if I add negative 1 and 36, that doesn't equal 0. So then I flip-flop them. I have 1 and negative 36. Well, those also don't add to equal 0. So let's think of some more. So I can do negative 3 and 12. Well, those also won't equal 0. They won't equal 0 if I flip-flop them. But what if I do negative 6 and 6? Those will add up and make 0. So I have negative 6x and positive 6x. So we're going to rewrite this, or rewrite this, with these two as the middle term. So I have 4x squared, and instead of 0x, I'm going to put negative 6x plus 6x, because when I put those together, it makes 0, minus 9. So now we're going to group. Group here and group here. GCF time. GCF for 4x squared and 6x is going to be a 2x. When I factor that out, I have 2x minus 3 left. And then the greatest common factor for 6x minus 9 is going to be a 3. When I take that out, that is a 2x minus 3 left. And so my two factors are 2x minus 3 and 2x plus 3. And so those are the two factors for this problem right here. Now, like I said, it is really something, it's a special product called the difference of two squares, and there is a shortcut to factoring it, but we don't know that yet. But it'd be really awesome if y'all paid attention to the answers and to the problem and see if maybe you can come up with a shortcut on your own. I would love to hear your thoughts. So let's talk about, we're going to practice this in class tomorrow. That's what we're going to do. You're going to either pick a method, box method or AC method, whatever works best for you. We will practice this when you come to class, and I will see you then.